A, B, C, D. A, B, C, D. There. It's parallelogram. The diagonals, A, B, C, D, intersect at 0. There's this at the center. AB is equal to 9. That's equal to 9. BC is equal to 6. That means the opposite. That's 6. That's also equal to 9. And the angle DAB is equal to 60. So follow DAB. That whole angle there is equal to 60. So what do you think this angle up here is equal to?
60.
Alright. The four angles, the four corners of a parallelogram add up to 360. So that's 60 and 60. That adds up to 120.
And 180 and 180 is 2.
Take that from 360. What's left? 240. So what's the size of this angle here?
240. No, that's 120.
Divided by 2. So this angle and this angle add up to 240. So that's 120 and that is 120. Right. Find DC. Well, that's easy. The length of the line DC is 9. Find the angle ABC.
120.
ABC. 120. Just did that. Name one pair, yeah.
Where do you find it now?
Where do I find?
9.
9. Well, this one was 9. So this one is parallel, is 9. It's a parallelogram. This one was 6 from the information they gave us, so this one was 6. Alright, this is 60. Yep, that's 60. All the four angles in a parallelogram add up to 360. Name one pair of parallel lines in the diagram.
DCAB.
Yeah, so you said DC, AB. Right, so you have to write it like this. DC and what did you say? AB. Is the statement DO, is DO equal to OB in length?
Yeah.
So DO is equal to OB because, we'll get onto that in a second, yeah. Is AO equal to OC?
Yeah.
Yeah. What's the reason for that? The reason is,
AB is equal to DC. And
in a parallelogram, diagonals bisect each other. Right?
Could you say this? AB is equal to DC and CB is equal to AD and BOA is equal to COD, therefore BO is equal to OD.
You could. Yeah. I'm giving you an easy way out. This is the definition. In a parallelogram, the diagonal lines bisect each other. That means cut each other in half. That's what you should write. In a parallelogram, the diagonal lines bisect each other. Next one. Construct the image of the parallelogram ABC under axial symmetry in the line AB on the diagram above. Alright. Axial symmetry. So the mirror basically is here at AB. So watch this. Right. So here's the mirror. So here's the mirror. If I'm standing at B, if I'm standing with my face against the mirror, am I going to move anywhere? No. If I'm standing here at A with my face against the mirror, which is the ruler, do I go anywhere?
No.
If I'm standing at D,
Yeah.
where do I go?
Towards it.
Straight through the mirror.
Towards the mirror and the same distance to the far side. So we need to draw a light line and another light line for C. Right? And we need to get that distance there. And the same distance far side. And the same for here. Same distance far side. So what does our new image look like? It looks like this. B hasn't moved anywhere. A hasn't moved anywhere. D has moved down to here. That's D image. And C has moved down to here, the image of C. So, right, the top one, looking through this mirror, looks like this, the reverse, isn't it? So this is the image.
Could you do it up there?
What?
Or do you have to do it where it says there?
It says, it said use the diagram above. This is the diagram above. Is that right?
So what length are the lines?
I use the compass
Or
to get that distance there.
okay, so
You could extend that line if you want, just so you can get it spot on to get that distance there.